And we're back with chapter 8, and we're going to cover the end of chapter 8. So let me, without further ado, do some screen sharing here and get that going on. So chapter 8, we're on objective 3. We're going to describe the Pearson R, which is a statistical measure of a correlation. We'll talk about 4 types of correlations and then how a correlation is described graphically. Okay, first, we have the Pearson R, or what's written out as the Pearson product moment correlation. And it is the statistical notation for a correlation. So we can compute a correlation from ranges of scores on 2 variables, remember. And so when we compute a correlation, we can get a range from +1 to a -1. And if we look at the absolute value of that number, for example, positive 0.6 would be the absolute value would be 0.6, and -0.6, the absolute value would again be 0.6. Then we can tell the strength of the correlation. So let me just show you a little activity there, and you can kind of see which is the strongest correlation there. Look again at the absolute value, and you should be able to see that the strongest correlation is the biggest absolute value number, which is encompassed in answer B. Okay, well, I want to talk about 3 different kinds of correlation. The positive linear relationship. So when you see that positive sign, or no sign at all means that it's positive, then we can assume that it is a positive linear relationship. And all that means is that both variables increase together or they decrease together. So for example, grades and hours studied. With grades and hours studied, we would assume that as hours studied goes up, so do grades, and that they also go down together. So as grades go down, so do hours studied go down. And there we can see the way it's displayed on what's called a scatter plot. And a scatter plot has each individual person, their number of hours that were studied, and the grade on there. And when the scatter plot starts to kind of make a line like that, we can see that that's a positive correlation. This line down here of this scatter plot is a negative correlation. So let's talk about the negative correlation, or the negative linear relationship. This is when one goes up, the other goes down. So here you can see that as the number of beers drank goes up, the grades go down. As the number of beers that you drink go down, then the grades go up. So they're going in opposite directions. One goes up, the other goes down. One goes down, the other goes up. And that is the negative relationship. So when you see -0.6, that means that one of the variables is going up while the other is going down. That graph there is called the scatter plot, as I was mentioning. And what we have when we draw a line, the best fit of that line, or draw a line through this one, that line is called the regression line. Okay, 2 more relationships between variables. Sometimes we can have what's called a curvilinear relationship, and that is linear refers to line, and curve just what you think it is. It's a curved line. And so that's when the relationship changes direction at some point. And so what's happening here is these are separation from jobs and ages. What happens with young people is that they're more likely to separate from their job. They're more likely to quit their jobs. But as we get older into 40, 45, people are very stable. They're very less likely to quit their jobs. But as they get older even more, they again become more likely to quit their jobs. And so that's the curvilinear relationship there. And then finally, we have no relationship. And when you have a scatter plot that's just all over the place like that, and you can't draw a line through it because you don't really have a gathering of points in a line, then that usually means that there's no relationship at all. So notice that the R in this case is very close to 0. R equals 0.06. And that is when it's close to 0, that means there's no relationship at all. So the variables are just independent of one another. You can't predict one from the other one. So note, a couple of notes on correlation. You cannot do a correlation if you're measuring things on a nominal scale or even an ordinal scale. You need to measure on an interval or ratio scale to be able to calculate this Pearson R. There's lots of variation in each variable that will make for a stronger correlation. So if you're looking, for example, at education, amount of education in college students, just about everyone is going to have about the same amount of education. You know what I mean? So K through 12 plus 1 year of college or 2 years of college or whatever. So the range is very, very small there. That's not going to be a good variable to do a correlation on. We want a much, much higher range of numbers there in order to do a correlation. Okay, finally, objective 4, describing the purpose of the chi-square and the multiple regression. Okay, a chi-square is like a correlation in the sense that you're looking for the relationship between two variables, but you use this test when one or more of your variables is a nominal variable, meaning like gender or like ethnicity, or in this case of that graphic there, support from monetary support from these various sources. So you have here you have the amount of students who are getting support from parents and family and from themselves, from scholarships or from other things. So if you did a study to see whether men and women finance college in similar or different ways, you could look at the number of men who were financing in these ways and the number of women who are financing in these ways. And what the chi-square test will tell you, so you can do a statistical test on these, and it will tell you whether men and women are different enough to be significant. So are men and women significantly different? Is there an important difference in the way that men and women finance their college education? That's for the chi-square. And again, you need to have a nominal variable there. Finally, multiple regression is used when you're trying to predict one variable from many other unrelated variables. So it's kind of like you have a whole bunch of variables, not just two like we would normally do with the Pearson R. You are going to have a bunch of other variables. So for example, let's say I was trying to predict the risk of an eating disorder like anorexia nervosa or bulimia nervosa. And I have all these variables. I have age of people, I have their gender, I have their weight, I have a variable called perfectionism, how much they want to be perfect, I have anger, I have their exercise habits. Rather than run separate correlations for each, we can run a larger test called a multiple regression, where we put them all in at the same time. And that will show us how strongly each one of those variables is related to eating disorders. So maybe, exercise habits are strongly, tightly related to eating disorders, but anger is not. This statistic will tell us that. It also tells us how much of the risk for eating disorders is accounted for by all of these variables collectively. Are we explaining 70% of the risk for eating disorders, or are we only explaining 20% using all of these variables? Are there a lot of other variables that we didn't measure, or is this encompass all of it? And so the multiple regression is very useful if you have a lot of different variables. That's all I have for chapter 8, and I wish you guys the best on the chapter 8 exam. Have a great day.